students, I hope all of you are doing good. Let's start today's chapter, decimals. You have to solve these orally and find out the quotient and remainder. Okay. The fractions in which the denominators are 10 or 100 or 1000 etc. or multiples of 10 are called decimal fractions or decimals. Tenths. Let us understand it with an example. Consider the following figure. The figure is divided into 10 equal parts and one part is shaded. The shaded part represents 1/10 of the whole. It is written as 1 by 10 or 0.1. We read 0.1 as 1/10 or 0.1. Similarly, if we shade 3 parts, okay, it represents 3/10 and we write it as 3 by 10 or 0.3, right? So, we read this as 3/10 or 0.3. The numerals 0.1 and 0.3 are called decimal numerals or simply decimals. The dot in a 0.1 and 0.3 is called a decimal point. 0.7 can be read in 2 ways as under. Okay, first one is 7/10. We can read it as 7/10 or as 0.7, right? Decimals and whole numbers. Whole numbers can also be renamed using a decimal point. Okay, how? 3 can be written as a 3.0. 5 can be written as 5.0 and 7 can be written as 7.0. The 0 after the decimal point means there are 0 tenths. Hundreds and thousands. Consider the following figure which is divided into 100 equal parts. Okay, this figure is divided into 100 equal parts. If we shade one portion of it, then the shaded portion represents 100 or 1 by 100. We write it as 0.01, okay. If we consider 5 such shaded regions out of 100, then the shaded region represents 5 by 100 and we write as 0.05, okay. Similarly, if we divide an object into 1000 equal parts, then each part is 1000 of the whole. 1000 is written in fraction as 1 by 1000. In decimal fraction, 1 by 1000 is written as 0.001, okay. Further, if we take one part out of 10,000 equal parts, it shall be 1 by 10,000. That is, which is equals to 0.0001. This we have the following. 1 by 10 is equals to 1/10 or 0.1. 1 by 100 is 100 or 0.01. 1 by 1000 is 1000th or 0.001. And 1 by 10,000 is equals to 1/10,000, that is 0.0001. Study and understand the following table. Okay, read this out. 5/10 fraction is 5 by 10. This is the decimal fraction and it is read as 0.5. 9/10, 9 by 10. Decimal, this is decimal fraction and it is read as 0.9. Similarly, 300, 3 by 100 and this is the decimal fraction and this is read as 0.003. Okay. Let's do exercise 9.1. Write each of the following as a decimal. 7 by 10 is 0.7. 3 by 100 is 0.03. Right? Next, converting decimals into fractions. Rule: take the decimal without decimal point as the numerator, then as a denominator with one add as many zeros as decimal places after the decimal is. Let's understand this with the help of an example. Example 1. Express the following as fraction or mixed numerals. You have this 0.75, okay. After decimal, there are 2 digits. So, we will add 2 digits in the denominator and then 1, okay. And you can also write it as in simplest form also. So, 3 by 4. Similarly, we have this decimal 0.035. Here in denominator, we will write 1000 because there are 3 digits after decimal, okay. Decimal fractions and place value chart. We know that place value of 5 in 852 is 50. Similarly, place value of 8 is 800 and place value of 2 is 2. So, we write 852 is equals to 800 plus 50 plus 2, which is the expanded form. Okay. Now, what about the place value of digits in 0.1234? Place value of 1 is, see, this, we have this decimal. Okay. So, the place value of 1 is 10th, 1/10th. Place value of 2 is 2 hundredths. Similarly, place value of 3 is 3,000th, and place value of 4 is 4 10,000ths. Okay. Let us consider another example, which is 0.349. 3 is in 10th place, right? So, the place value is 3/10 or 0.3. See, 0.349. Place value of 3 is 3/10 or 0.3. Okay. Similarly, place value of 4 is 4/100 because 400th is the place value or 0.04. Okay. And place value of 9 is 9,000th or 0.009. Right. Also, we can write it as, see, how can we write it in expanded form? We can write it as 3/10 plus 4/100 plus 9/1000. Okay. Or you can write it also as 0.3 plus 0.04 plus 0.009. Okay. Similarly, we will do this example also. Okay. Like and unlike decimals. Decimals having the same number of decimal places are called like decimals. For example, 0.25, 0.81 and 0.21, etc. How these are decimal, like decimals? Decimals, how these are like fractions? Because they have same number of decimal places. Means after decimal there are 2 places. Okay. And decimal fractions having different number of decimal places are called unlike decimals. For example, 7.8, there is 1 decimal place. 4.12, there are 2 decimal places, and 9.123, there are 3 decimal places. Okay. Comparison of decimals. Rule: to compare 2 or more decimals, first convert them into like decimals, then compare the whole numbers. If they are same, compare the 10th digit. If they are the same, compare the 100 digits, and so on. Example 1, compare the following decimal pairs. Okay. So, you have 4.32 and 2.8. So, according to rule, first what will we do? First we will convert it into like fractions. Okay. See, there are 2 decimal places, but there is only 1 place, 1 decimal place. So, we will add a 0 here. Okay. Now, what will we do? First, we will compare the whole numbers. Whole number is 4 and here 2. So, which one is greater? 4. Okay. Next is 9.32 and 9.38. Okay. So, 2 decimal places, 2 decimal places. Okay. Now, let's compare the whole number. Here is 9, here is also 9, same. Then compare the 10th place digit, which is 3. Again, same. Then we'll compare 100, which digit is at 100th place. Here is 2, here is 8. Which one is greater? 8 is greater, right? Example 2, arrange the following decimals in ascending and descending order. Converting the above decimals into like decimals, we have this. Okay, first we will convert all these decimals into like fractions, then we'll compare, and then we'll arrange in ascending order, and then we'll again arrange in descending order. Okay. Example 3, write 295.3456 in the place value chart and write down the place value of each of its digits. So, let's write these digits in the place value chart. See, you will write hundreds, tens, ones, then there will be a point, then tenths, 100, 1,000 and 10,000s. Okay. So, we have whole number 295. 2 is at 100th place, 9 is at 10th place, 5 is at 1st place, then point. Then at 10th place, there is a 3, that at 100 plates, it's 4, then 1000 place, 5, then 10,000 place. Okay. Now, what we have to do is, we have to write down the place value of each of its digit. Okay. So, we'll write 200 plus 90 plus 5. Okay. Now, 10th place, there is a 3 at 10th place. So, we'll write as 3/10. Then 4/100 plus 5/1000 plus 5/10, 6/10,000. Okay. And place value of 2 is 200, of course, because it is at hundreds place. Okay, we have this number 295 decimal 3456. So the place value of 2 is 200, place value of 9 is 90, and place value of 5 is 5. Place value of 3 is 3 by 10. Place value of 4 is 4 by 100 because it's at 100 place. Place value of 5 is 5 by 1000, and place value of 6 is 6 by 10,000. Okay, let's do exercise 9.2. Fill in the circle with greater than, less than or equal to as the case may be. A. 3.45 and 2.921. We have to compare these two decimals. First, we will convert these decimal into like decimal. Okay, there are 3 places. After decimal, there are only 2 places. So we'll add 0. Now let's compare. First, we'll compare the whole number. Here is 3, here 2. So which one is greater? 3. So this number will be greater, or this decimal will be greater than this decimal. Okay. Addition of a decimal fractions. To add 2 or more decimals, we follow the procedure given below. Rule 1. If the given fractions are not like fractions, then change them into like fractions. Rule 2. Arrange the number in column form so that the decimal points of all the addends are in the same column and digits having the same place value are in the same column. Rule 3. Add the digits as in the case of the whole numbers. Rule 4. In the sum, put the decimal point directly below the decimal points of the addends. Let's understand this with the help of an example. So we have 8.32 and we have 11.732. Okay, first let's first convert it into like decimals. Okay, we will add here 0. Now arrange in columns. 8.320, then we'll put a dot here. 73211. Okay, now add 2 plus 0 2, 3 plus 2 5, 7 plus 3 10, 1 carry, and don't forget to put the decimal. 8 plus 1 9 plus 1 10, 1 carry, 1 plus 1 2. So 20.052 is the answer. Okay, let's do exercise 9.3. Add the following. 7 plus 5 12, 0.5 and 0.7. 7 plus 5 12, 1 carry, then here 0 1. So 1.2 is the answer, right? Subtraction of decimal numbers. Like addition, we subtract decimal numbers as we subtract whole numbers. We follow the following rules. Rule 1. If the given decimals are not alike, we convert them into like decimals. Rule 2. Arrange the numbers in the column form so that the decimal points of both the numbers come under the same column. Also ensure that digits having the same place values are in the same column. Rule 3. Subtract as in case of the whole numbers. And rule 4, in the difference, put the decimal point directly below the decimal points of the two numbers. Okay, example. Subtract 8.1 from 16.25. Okay. Converting the decimals into like decimals. We have to subtract 8.1 from 16.25. Okay. 8.1, when we'll put 10 here and then we'll subtract. Okay. Always remember, you have to put decimal point directly below the decimal points of the two numbers, right? Now to subtract, 5 minus 0 is 5, 2 minus 1 is 1, decimal, 16 minus 8 is 8. So 8.15 is the answer. Similarly, we will subtract these examples also, okay? Let's do exercise 9.4. Find the difference. 36.46, 16.37. We cannot subtract 7 from 6, so we'll borrow from here. 16 minus 7 is 9, 3 minus 3 is 0, then decimal, 6 minus 6 is 0 and 3 minus 1 is 2. So 20.09 is the answer, right? Equivalent decimals. We can rename a decimal by writing as many zeros as we like after the last digit in a decimal number. See the two figures below. See, 2 tens means 2 by 10 or 0.2, and 20 100 means 20 by 100 is equals to 0.2 0. The shaded square above shows that 0.2 is equals to 0.20. Okay. So you can add as many zeros as you want after the decimal. Okay. So 0.2 is equals to 0.20 is equals to 0.200 is equals to 0.2000. Okay. These are the equivalent decimals. Tenth can be renamed as hundreds and as well as 1000. 0.1 is equals to 0.10 is equals to 0.100. Hundreds can be renamed as thousands, like 0.06 is equals to 0.060 and 0.69 is equals to 0.690. Okay. Money and decimals. We know that 100 paise make 1 rupee, that is 100 paise is equals to 1 rupee, or this is a symbol of rupee. 1 paise is equals to 1/100th of a rupee, okay, that is 1 by 100 is equals to 0.01 rupee. 8 paise is equals to 8/100th of rupee, that is 8 by 100 is equals to 0.08 rupee. 10 paise is equals to 10/100th of a rupee, that is 10 by 100 is equals to 0.10. Similarly, 25 paise is equals to 25/100ths of a rupee, so 25 by 100 is equals to 0.25 rupee. Also, we know that 84 rupees and 75 paise in figures is written as this. Okay. This shows that we use a decimal point to separate rupees from paise. To convert rupees into paise, we multiply the amount in rupees by 100. Okay. For example, rupees 6, we have to convert it into paise. What will we do? We will multiply it by 100 paise. So, the answer is 600 paise. Similarly, we will multiply these 2 rupees by 100. To convert rupees into paise, multiply the amount in rupees by 100 and add it to the number of paise. Okay, now we have rupees 12 and 40 paise. Okay, so we will convert only rupees into paise. So 12 into 100 paise is equals to 1200 paise, and we'll add this amount which is 40 paise to it. So the right answer is 1240 paise. To convert paise into rupees and paise, we put a dot after 2 digits from the right of the given number showing paise. The numeral on the left of the dot indicates the number of rupees, and on the right of the dot indicates the number of paise. Okay, see, right of the dot is paise and left of the dot is rupees. Okay, so 3975 paise. So we'll just put a dot. Okay, so this is 39 rupees and 75 paise. 100 in paise is equals to rupees 1.10, means 1 rupees 10 paise, and 30 paise is equals to rupee 0.30. Okay. In right of decimal, it is compulsory to keep 2 digits. Okay, like 8 paise is rupee 0.08. Okay. Okay, take care. Okay, 9 paise here, 0.09. Take care here, 0.9 will be wrong because it will be 90 paise. Okay. Now, addition and subtraction of money. Addition and subtraction of money is done in the same way as that of decimal numbers. Procedure. Step 1. Express the amounts in numeral form if they are not already so. Step 2. Write the amounts in numeral form under each other so that the decimal points are in line under one another. Then the digits in the tens place, 100 place, ones place, tens place and so on will be under one another. Step 3. Add or subtract as you would do in case of whole numbers. Right? Example 1. Saurav purchased a geometry box worth rupees 5 rupees and 60 paise and a pencil box and a pencil 3 rupees 10 paise. How much did he spend in all? So we have to add these two amounts. Okay. So how will we add? At ones place, there is 5, then dot, then 10th place there is 6, then 0. And then again at ones place there is 3, then dot, then at 10th place there is 1, then 0. And now we will add them up. So the answer is 8 rupees and 70 paise. Okay. Exercise 9.5. Rename the following as hundreds. Okay. 0.8. We have to rename them as hundreds. So what will you do? You will add 1 0 here. Right? So students, now you will do the practice of the remaining questions.